Okay, our next talk is about Kubernetes on Nix. Let's welcome Lux.
Hi, everyone. So I want to talk about Kubernetes on Nix, and I work at Data Dynamic here in Switzerland. I study at the Humboldt University in Berlin and currently work in both occasions with Kubernetes and use Nix as a host for it. So first, what is Kubernetes? I think most of you know it, I hope. So Kubernetes is, as we know, a cluster manager. So it allows our applications to scale horizontally, and it gives us high availability. Both is cool, but we still need some host under it. And also, we really like the reproducibility of Nix. So what feels, in a way, very similar between Kubernetes and Nix is both have a very explicit idea about state. In Nix, we try to have our state mostly derived from our Nix expression. We want to clearly separate our application config, which we have stateless, as we say in our Nix, and our data. And Kubernetes does the same because of different reasons. And the system config in both cases comes from a very clear defined source of truth and is clearly separated from the application data, which is somewhere externally. So that feels like an obvious match for me. But what's the primary difference? I think it is that the source of truth in Kubernetes is a bit more complex. It comes from an etcd cluster, some YAML files we put into our etcd cluster. But while almost all state is kept in the etcd cluster, there is a thing that I would call dynamically derived state. For example, we have like replica sets or deployments that create pods and remove them. For example, if we lose a worker node, worker machine. So we have this derived state, and so we have like a mix between dynamic and static state. So I think that's something to keep in mind when working with that. Then the core thing we need for our Kubernetes cluster to work is a control plane. Everyone talks about the Kubernetes control plane in comparison to our worker nodes. So how does this control plane work? What is it composed of? The control plane primarily provides an API that can be used by our kubectl, which we use to interact with our cluster. Then it changes the state of the cluster depending on, well, what we want. We want a deployment. We say we want to have always 5 running pods for our application, and then we add worker nodes, or like we lose worker nodes because they crash or whatever. And so this dynamically derived states needs to be computed. But the entire control plane, and I think that's very important, is not necessary for the applications to work correctly. Right? If we entirely remove the entire control plane, the applications will continue to run, continue to work. The only thing we cannot do is change anything about the cluster, and we cannot even change like some derived state. We cannot explicitly change the state, but it also will not recover from broken nodes or any other broken thing. So the core component of the control plane is the etcd cluster and the API server. And I think it is very important to understand that the only thing that talks with the etcd is usually the API server. There are very, very uncommon exceptions, but that's how it should be. And the API server is completely stateless, just an API server, talks with the etcd, word is fine. That thing has no state. The etcd cluster has state, and it is also the only node that it communicates with other components of its own kind. So the etcd nodes talk with each other to synchronize the state, but the API servers do not talk with other API servers or in any way like that. Then we have the other 2 core components that, in my experience, create a lot of confusion, are the scheduler and the controller manager. And I think it helped at least me a lot to finally realize that both only talk with the API server and keep no local state and only create this derived state. Both are in that way very similar. They care about a bit different things. While the scheduler assigns pods to nodes, the controller manager creates pods, removes pods, and does a lot of various things in multiple controllers, but both derive state. So that's simple. And both work in an active standby mode, so only one controller manager and one scheduler is always active, and the others are in standby. That's interesting if we want to have a very, very small cluster. We can just only use one of each, or if we have like another kind of failover system for them to like save resources in a very, very small home setup, maybe that's something we can do. So then, with all that put together, a typical control plane setup looks like this. We have multiple servers, in this case 3, all have like at least an etcd running, API servers running in front of it, and we have like some load balancer running in front of the API server. We need some kind of load balancer here, but it does not matter at all what kind of load balancer it is. Of course, we can also absolutely always connect to only one controller, but then if that one crashes, that's gone, but it works, right? Like it's absolutely no reason to this load balancer is what like removes our single point of failure when calling our API for us when we use kubectl, or for the worker nodes later. So some things I didn't completely mention yet. It's not really relevant, but I think important to know that while both controller manager and scheduler expose an HTTP server, that is not really something we need. It provides us logs, it gives us health, that's all cool, but it works without. That is not a core component. And I think that really clears some things up, at least for me. Then the worker nodes, just mentioned. The worker nodes have basically usually two components running. One is the kubelet. The kubelet is, in a way, the core Kubernetes component. It runs pods. Very simple. It does not really do much else. It communicates with the API server, and the API server tells it which pods it should run, and then it does that. And there's the kube proxy, which is the component that provides services in our cluster. Our cluster works without the kube proxy if we don't use services. That's totally fine. No reason not to do that. Only that we usually want services, but it works. Also, the kube proxy and the kubelet do not really talk that much with each other. Both talk with the API and configure each other. We have some kind of CNI that gets a bit out of scope here. We only have 25 minutes. So, I want to talk about certificates, because in my experience, certificates are the pain thing. People are laughing. When I started, or we started trying to use Kubernetes, we realized that we need like 1,000 certificates, and we had no idea why or what they do. So I think that's something I really want to clear up a bit. I also want to present how we finally do certificates. So we need, for a working Kubernetes cluster, at least 2 certificate authorities or more. And yes, we need them. And no, using ACME is usually not a solution. So let's have a look at what needs certificates. So that are all the components we have, all the components I talked about. We have here the 3 etcd nodes that talk with each other. So they need certificates both as TLS server certificates and TLS client certificates to talk with each other, server certificates to, well, authorize itself. And all these certificates have a very simple trust model, usually. The trust model is, if the CA signed it, I trust it, and you have access. So that's why we need a CA for that. Perfect. That's the first CA. And that's one we usually absolutely need, and we don't want to use for anything else, because every certificate we sign with it is a valid client certificate for our etcd cluster, which is our source of truth, so not a good idea. Then we have the API server, scheduler, kubelet, and controller manager, all exposing an HTTP server. So we need TLS server certificates. These are pretty simple certificates. We could use ACME for them. That's just a normal server certificate. Fine for that. That's the easy one. Then we need client certificates for everything that talks with our API server. That is here, 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 and here. We need this API client. We usually, for all these cases, we need a kubeconf, which is a simple config file where we put like the client certificate with key, the CA that we trust, so this is the TLS CA used by the HTTP server or from the API server, and, well, an URL for where the API server is to be found. That's some load balancer usually, or localhost in cases for scheduler or controller manager if we have one running on each master node and we don't want them to continue to work if the API server crashes on that node. That's totally valid. And then we have a final thing. We have this back channel. That's a bit an annoying back channel, but it is necessary for the API server to talk with the kubelet only and only for logs and for exec. That's the only thing. If you don't have that, everything else works. So you have a working cluster, you can just not debug it. I don't like that. So let's have a look at what certificates we need. etcd, I already said it. We have all these Nix options packaged in Nix, and we can use it. We can use the etcd server as it packaged in Nix. That is fine. We just really need to provide a lot of certificates. Works. We need basically two kinds of certificates. Usually it's fine to use the same for both client-to-peer and peer-to-peer communication in etcd. And yeah, as I mentioned, TLS certificates are very, very normal TLS certificates. And yeah, I think I talked about that. So yeah, the kube config, that's something very useful. Like for when you use the Nix modules provided to configure a kube controller manager, scheduler, kubelet, or whatsoever, there's usually this kube config, and there is, as I just mentioned, the server, is the API server, and then you have the CA file. This is the CA file that the TLS certificate used by the API server as server certificate, which does not have to be the same certificate authority as your client certificate. So, and that's used by everything. So that's in a way the most important certificate. Yeah, the kubelet client, this is this back channel. We use here a separate CA just for that, to have it separate. And yeah, how to create these certificates. A lot of certificates. How do I create them? Well, there is this thing in NixOS where you can use services, Kubernetes, API, Gen, CFSSL API. No, yeah, PKI. Ignore the last thing, it's a copy-paste error. But this is basically only for, docs say only for single master node, and it requires you to use some kind of join mechanism if you add a new node. So I suggest a different approach. I suggest to use Nix secrets with some kind of Nix secret management. Subsnix, for example, or agenix. We use agenix, but yes, that would work. And well, why not? We have a secret deployment tool. That's very cool. Why not use it? So what do I suggest? I would suggest we store all certificates encrypted in the Flake repo. We have some kind of script to generate them. We need a way to define the certificate authorities independent of our certificates and independent of our hosts. And then we can just define our certs and use them. So, and then use something like agenix, as I said. I have an example implementation here. This is just extracted basically from something we use and like rewritten in better and absolutely work in progress and just some snippets I share, but it maybe gives some code to use. So what do I want? I want something like, yeah, let's say we have a cert in this directory in my flake. And yeah, well, I have certificates, certificate authorities. And then I want to define my certificates. Basically simple. I want to say, yeah, this is my certificates. Cool. This is what I want. And then I want to be able to use them in my config. Very simple. Like the same way I use my certificates with my secrets with agenix, I want to just use my certificates. So how do we do it? Then we need some script to generate them. We can just overwrite every certificate that is not a certificate authority, because why not? It's still signed if it's signed. And then we add it to Git and deploy, and we are fine. And we have a working cluster. So how do we do that? I think one thing is to mention we can just evaluate a module. So we just do that, disable some code that creates our Arc integration, and then we can have everything with that we can basically generate a script, iterate over all the certificates, generate some script, use this CFSSL, and generate all certificates. I don't have the time to show all the code, but that's how it can work. We can just encrypt it all, put it in our repo, world is fine. And we can then configure, for example, agenix here, just configure it and use it. Like we can use config secrets.path, I have our secret, steal that, and we can configure it. So I think that's a very cool approach to configure certificates in Nix, because it means I can just completely destroy my entire cluster and recreate it. It's very cool if I want to have a test cluster. Like that gives me a test cluster in seconds. So the other thing that I really wanted to do then is, because my cluster is still not done, there are still a lot of YAML files I need to apply first, for example, when I set up a test cluster. So there's this very cool thing that is called the addon-manager. The addon-manager is basically a very, very simple shell script packaged in Nix that synchronizes a file system with my cluster. It just reads YAML files, applies them, and the fancy feature, if we set addon-manager Kubernetes IO mode to reconcile, it will also delete them if we remove them from the file system. That's cool. So we can create the YAML file folder with Nix and have it deployed in our Kubernetes cluster. A lot of state just moved to our Nix config. kubnix, I think, is something that could help generate these YAML files, but I think in combination this can be a very, very powerful thing. I haven't really experimented with kubnix yet. And that's how it looks like. We just can set Kubernetes addon-manager add-ons, and that's the YAML file. That works fine. And we can even use Nix syntax, and we can use Nix functions to generate our YAML files. I love it. Then final thing that I found is there are these weird large add-ons, like a cert-manager, that is to generate public certificates for our ingress and so on. And they say, yeah, you can install this thing, just do this. I don't like that. Like some random YAML from the internet, I hope it's always the same if I put 1.18.2, I hope. And yeah, cool. But what I did is a very simple, like if you have the addon-manager, why not write a simple derivation for these kind of large YAMLs? So I did it, and I have a little example implementation there that can be used, and I think is quite useful. So how can it be used? It can be used like that, like just say, okay, here's my source. I have a hash now. That's better. And what does it do? Well, not much. And I think that my main point here is a lot of things can be done with Nix to configure in Kubernetes. There is no magic. There is no magic. Just look into the source, try around, and it's less magic than it looks like, because it always looks like a lot of magic, and everyone talks about it's a huge thing. So how does it work? Yeah, well, simply, it's a simple derivation. We use YQ to convert the YAMLs to JSON and then just configure the add-on manager, well, why not? And we always add the Kubernetes IO mode to reconcile, so that works. So finally, I think Nix is a great foundation to build a Kubernetes cluster. And I think while the state is kept in the etcd, that's not that bad. We can handle with that. We need to understand that the API server is a core component, and all the components just talk with it, and that makes like all the complexity that looks everywhere is much reduced. So yeah, here I have some example stuff. I will try to hack around on that maybe tomorrow. Come find me if you have something you want to discuss, and I think we have 5 minutes for questions.
Great talk, thank you, Lux. Why do you generate the JSON from the YAML at build time instead of at evaluation time from a NixOS module? Like we have functions for generating YAML in the library.
It's not about generating YAML, it's about parsing YAML.
Oh, then I might misheard it, sorry.
How do you add another node to your Kubernetes cluster? Do you regenerate all certificates, or how do you do that?
Currently, with this implementation, I currently do that. I could also have extend the script a bit to check if the certificates already exist, and if the expiration time is far enough in the future that I only regenerate if the expiration time would change significantly or so. But yeah, sure, why not regenerate all certificates? That's fine. Not the certificate authorities, but the certificates.
Any thoughts on extending Nix management to cluster content? Or managing cluster content also with Nix?
Yeah, well, that's what I use the add-on manager for, right? We can just use the add-on manager to describe any kind of YAML we want, and then deploy it, and then it will be added to the cluster. How we get our containers created is an entirely different story.
Any experience with Kubernetes, maybe?
No, I mentioned it. I think it's a great solution probably to generate all these YAMLs we can then deploy with the add-on manager.
How much time does it say? Okay, yeah, we got plenty. Okay, sorry. Next.
Do you have a take on containerized solutions like RKE2 or Keys, which also are bundled on NixOS, versus manual management of Kubernetes clusters?
Well, I mean, I really like it that I can destroy my entire cluster. And actually what we do at work is we generate we can generate the entire cluster as VMs and start it with a single command. And generate the entire cluster basically as VMs with the Nix VM generation, and then we only need to inject the SSH host key and boot it. And everything else just works. And I really like this approach because it removes all this kind of manual management. 90 seconds.
Yeah, it's okay. It's okay.
Thank you. I really like the administration side of using Nix to admin the cluster. For the user side, or you call it configuration, applying configs, what advantages do you see there over something like Argo CD and having that watch your Git continuously deploying?
Well, why have two tools if I have one that can do it? Basically, I I think like having it connected to my entire Nix config means that if I upgrade my cluster in some kind of way, I can do it all in a central place, have a central commit history for all changes, these kind of management things.
Okay, so I think we're up. I think the time is up. Of course, we're up.
Yeah, well,
yeah?
if you have any more questions, find me later or tomorrow.
Okay, so let's thank our speaker again.